I'll let you know when to unmute, so hang tight with me, okay? Thank you for joining Nearpod. We have 13 kids, and the first thing I wanted to point out was my incredible example I found in yesterday's grading. I don't even remember who this was, but it was so good that I had to show you. And so what this child has done is label the pictures. Raise your hand if you have ever heard Mrs. Cruz say, label your pictures, label them. Yes, you know you have, or I have texted it to you. Oops, somebody is unmuted. Could you go ahead and mute for me? Thank you, my loves. All right, so yes, this is a great example. So when you're drawing a picture,
sorry, Miss Cruz. Can you give me the code again? Because she didn't see the code.
Sure. I put it, it's up at the top. Can you see it on my screen, the top left?
Yeah, HKRJ7.
Yep, okay. And so this is a great example of what labels really do look like. They're tiny little words inside your diagrams and pictures. So in science, anytime you're drawing a picture, label it. Tell me what those objects are that you're drawing. All right, guys, stay muted for me so I can finish up and get to the good part. I know you're excited. So our labels, that's one thing I wanted to show you. Now we can actually go on to our lesson. It is erosion. We're going to talk about erosion. So let's talk about our standards and what we're doing today. So today you are going to be able to explore how the Earth's surface changes. It's changing every moment of every day. Even when you sleep, the Earth is changing for lots of different reasons. All right, so we've been looking into that a bit with our lessons. We're going to test it out today. So you'll also be able to make observations, whether that is with one of your senses. You're going to be able to determine what's happening on Earth's surface by making your observations and see how they have changed. And then you're going to be able to record your observations, because all good scientists write down their findings. They write down everything. Okay, so here we go. Okay, I'm sorry, I don't know who that is. Arna, what's going on?
I used to to bring candy, so I don't have all of that candy. So I bring, jelly drink.
Arna, can you stop for a second? 2 seconds, okay? Stay muted. If you have any concerns, you can text me. I want to get through the lesson as fast as I can. And this is optional. You can just watch. All right? If you don't have the candies, it's okay. You don't have to do it. All right? I'm afraid I'm not going to get to the lesson, guys. All right, hold tight. Have your parents text me if there's any kind of problem. Please. Okay, here comes our video. Okay, what do you already know about why the Earth's landscape or surface keeps changing? What do you already know? I know something changes it. Have you done some observations outside? Why is it happening? Oh, there's something that comes out of the sky that changes the Earth's surface. Oh, there's something that that happens in the air oh yeah, there it is, Ava. Rain, wind, and sun. Absolutely. Those are, and light too. Yeah, light can fade. You're right. Ooh, awesome. Benito's noticed cracks. I wonder what's causing that. The sun, Prisha, very nice. The moon, yes, the moon can actually cause changes. You're right. In the tides. Anything else? Ooh, here comes another one. Julian, wind and rain. Christina, snow. Almo, cracks in the sidewalk. Absolutely. Anyone else? Ooh, look at all this. Oh, gravity. Very nice, Vashvik. All right, great work. If you didn't get a chance to answer, it's okay. You're doing an awesome job telling me what you already know about Earth, the changes on the Earth's surface. Excellent. Good work, guys. Let's keep going. What is that? Okay, now I need somebody to tell me what's going on in that picture. Anyone want to tell me? Jaden, go for it.
Looks like it's flooding.
It looks like a flood. Yeah, that's true. It could be much higher than it used to be. So the water is flooding the area. Then what's happening? Who else wants to tell me? Thank you, Jaden. Who else? Vashvik, what's happening? What's the water doing?
It's due to strong wind. The strong wind is pushing the water hard.
Okay. All right. So maybe the wind is what's pushing or making the water crash into the land. And what's happening to the land, guys? Tell me what's happening. Michael.
It is filling up with water.
Okay, yeah, for sure. When soil gets wet, it gets really muddy and heavy. Now, where is that soil going? Can anybody tell where it's going? It used to come all the way out here. Well, what's happening to that soil and grass? Oh my goodness. I'm looking at Julian. Where's it going?
Underwater.
That's right. It's crashing. It's falling. It's cracking. It's disappearing. That's right. It is falling into the water and disappearing. Great job. All right, let's see what happens next. I mean, we're going to be looking at this the whole time, aren't we? Uh-oh. Oh no, what's happening? More of it fell down. Brooklyn, what did you notice? What did you observe?
The earth is breaking. The water is breaking the earth.
That's right. Oh, how scary. I shouldn't show you my backyard, but that's exactly what's happening in my backyard. It's falling into the pond. So I have to fill it back up with soil and grass. Otherwise, I'll lose my yard. All right. So today's lesson, we're going to talk a little bit about erosion and what happens when weather, water, air, anything hits our Earth's surface. What happens to the objects on Earth's surface? Well, we have rocks, don't we? And we have 3 different kinds of rocks that we know of. And one of them, oh, well, actually, there's more than 3. But the 3 main types of rocks that you'll find out in your yard are igneous, sedimentary, and metamorphic. Don't have to memorize those, but you do have to know that there are things that happen to those rocks over time. Some rocks are really strong and they don't erode very easily. Other rocks are kind of soft. Yeah. So our candy is going to represent the 3 different kinds of rocks. Let's see what we have. I have M&Ms. And the M&Ms represent our igneous rocks, which are like, have you ever seen lava? Yeah, raise your hand and you know what lava is. It comes out of a volcano. That's a type of rock. When it cools, it turns into what's called an igneous rock. Igneous, what a funny name. Now, we also have sedimentary rocks. Everybody pick up your soft candy, your Smartie, or whatever you have. I think somebody had a vitamin, nice and soft. You know that it'll break apart real easily. That's called our sedimentary rock. And that is really like, almost like sand and tiny particles put together. So it comes apart very easily. Now we have our hard rock. And I could only find the Lollipop Jolly Rancher. So there it is. I have a Jolly Rancher lollipop, but if you have a hard candy that does not come apart very easily, that's called a metamorphic rock. And that is a really old rock. We're talking like granite. If you've ever seen a granite countertop, right? It's that hard rock. Whoops, somebody's coming in. Hold on. So we're going to explore how weather can erode or change the rocks, or do they change the rocks over time? You know, there's rocks all over the earth. So the weather will change the earth. If it changes the rocks, it's going to change the earth, isn't it? So let's talk a little bit more before we begin. Our question of the day will be, does moving water, okay, water that moves. Ooh, I'm waiting for an example. Does moving water erode or break apart rock faster than water that is standing still? That's going to be our question. Does moving water erode or break apart rock faster than standing still? But hold on just a second. Johnny, why are you unmuted? I can hear you. Thank you, my love. So, does standing water erode? What if we just stepped in a puddle or put a rock in a puddle? How would that change? So let's talk about it for a minute. Who wants to share? Okay, so now before I call a name, my question is, what do you think will erode or break apart rocks faster? Moving water or standing still water? Siddharth? And why?
Moving water, because it crashes to the rock. If it's still, it doesn't crash.
That's right. Very nice. Wonderful job. And how about Brooklyn? Did you have something you want to share? A thought you want to share about it?
Yes.
Go ahead.
The fast water, it could break the rocks, pieces of it.
Absolutely. Do you remember from the last couple of, well, I think it was module 2, and we had a couple of different, it was like pushes and pulls.
Yeah.
Yelini? Thank you. So what is that called? Pushes and pulls are called two types of what?
Motions.
Yes, could be could cause emotion. Joshua, what are they called? Thank you, Joshua. What are they called?
Force.
Force. That's right. So thank you, Joshua. Force, right? So the water is forcing the rocks. That's right. Pushing up against it, pulling it away. Very good, guys. So just want to make that connection that we do have force in other areas besides pulling a wagon, right? Objects on Earth have force too. So let's talk about this. We have a hypothesis. We're getting ready, guys. A hypothesis is like what we think will happen. We think, thanks to your thoughts about it, that rocks will erode or break apart faster in moving water. So we're going to test it out. Yes, we are. Here it comes. Now for the fun part. Look, we're going to test out our hypothesis. We're going to create our experiment by having 2 cups of water or 2 baggies. So get those ready. And you're going to put water in each container. About a half a cup is fine. And a half a cup.
I have jaws. I have jaws.
Thank you. Thank you. Could you stay muted for me so I can give the directions? Thank you, my love. We're going to get a chance to talk, I promise. So I'm going to go ahead and show you if I can. So who had a question for me? Somebody had a question.
Is this enough water in the baggie?
Yes, I love it. About a half a cup, which is not very much. So I'm going to show off. Oh, you can see it in my screen right by my fingers. Look at my finger wagging. So I have my containers and they're about half full, my little containers. It's kind of like a jar. And now we are going to put our candies in. Now what we're going to do is take one M&M and put it in each container. So one M&M in this container and one M&M in this container.
But I don't have an M&Ms.
And then you're going to take your soft candy, your Smartie or whatever you have that's soft and crumbly, and you're going to put one in each container too. Look at that. Yes. Okay, but don't eat them. And then we're going to put our hard candy in. So here we go. I have to break it apart. It's a Jolly Rancher lollipop, but I'm going to put one piece into one of the water containers, and then one goes in the other one. So now, that was tasty. Here comes the difficult part. Trying not to let the water spill. That's the hard part. So here's what I have. We're going to test out, oh my goodness, do you see anything changing already? We're going to test out our hypothesis, which is if moving water creates a change faster than standing still water. So we're going to picture maybe an ocean versus a pond. A pond, the water just sort of sits there, right? But the ocean is crashing with heavy waves. So we're going to test it out. Choose one of your containers and close it up tight. Close it up tight. And you're going to shake it. Shaky, shaky, shake. A shake, 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 shake. Shake, 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 shake. You're going to create, what is this trying to create? Anybody know? Trying to do or resemble? Oh, Jaden, is this like when you go to the beach? Or maybe like a washing machine? Wow, a tornado in the water. Keep shaking. Don't stop. You're gonna get tired. Oh, look at Michael. Wonderful. Brooklyn's really shaking it. Make sure you don't spill, guys. Larissa, is this enough shaking, do you think, or keep going? What do you think? Stop. Okay, everybody stop. Now it's time for us to observe. Observe. You know, with all of your senses. You could use your eyes. You could smell it. Don't taste it. Well, maybe you want to taste it later. If it's candy, if it's not candy, don't taste it. Let's see what else. Whoops. Now, what do you notice? What do you observe? Larissa, can you tell the difference? Go ahead and talk to me.
So I can tell that the what is that called? The Jolly Rancher? Wait, no, the M&M melted. I mean, they're like
Yeah. Wow. So in both
that's
cases,
weird because I don't see like the chocolate in the M&M.
oh, that's a good point. Might still be in there. But thank you, Larissa. Thank you very much. Anyone else have any other observations? Look at yours. Did you notice anything change? Brooklyn, go for it.
This is like it's a little bit like foggy, and this one is like a little bit more foggy.
Wow. So you'll notice that the colors did come off, right, Vashvik and Brooklyn? Did you notice that the colors disappeared, blended with the water? So in both cases, whether it was the standing still water or our moving water, in both cases, it sort of took the color off, didn't it? But what did the moving water do? Oh my goodness. You know what I noticed? I observed something about the Smartie. What did you notice, Ava?
Oh.
I noticed that. Wait, what? You mean the Jolly Rancher or the Smartie?
Yeah, I'm looking right in the middle of my screen. First of all, the water's cloudy, and I think something mixed with the water more. And then I noticed something about my Smartie. Look at the size of the Smartie. In my moving, crashing water, my ocean waves, what happened to the size of my Smartie? Christina, can you tell?
Really?
Who notices my size? Blake? Yeah? Thank you, Christina. Blake, what did you notice?
The smallest.
It did. Let's shake it some more. All right, close up your moving water container again, and let's shake for about another minute. We better sing our ABC. A, B, C, D, F, G, H, I, J, K, L, M, N. Ooh, look at Siddharth stirring his. Wow, really get those ocean currents moving round and round. Whoa. Blake is shaking his. Look at Jackson. Ashvik, is there a way you can mute so I don't hear? Thank you. Ava Marie, don't forget to mute, please. Awesome. You're going to make my next observation. Get ready. Okay, we're getting ready. Should we stop? Let's see. Zara, do you think it's time to stop? Okay, here we go. Open it up. And let's observe. If you have a bag, don't open your bag. Just look through it. Oh, it's so stuck together. Oh my goodness. Look at the difference. Can you guys see what's changed? Zara, can you tell from my picture? Can you notice any or observe any differences? Anyone else? What do you notice? Almo, what did you notice? Who's a super size? Siddharth, you're next.
Excuse me?
Did you notice?
And every time I shake it, I can see chocolate.
Oh, so you're starting to see the center of the rock, right? The chocolate's coming through. How about Siddharth? Thank you, Almo. Siddharth, what did you observe?
Actually, I put in chocolate, so the chocolate thing, when I stirred it, the chocolate's coming out, and it's like in the water, there's like dots, brown dots.
Fantastic. Oh, that is so wonderful. You know, I can hardly see my M&M anymore.
So actually, the M&Ms in mine look like before, it looked like Earth.
Really?
Yeah.
Aw. So imagine this was your backyard. Yes. And all of the rushing water from the rain, or maybe one of those tropical storms comes. Ooh, or imagine you live on the ocean, right there on the ocean, on the edge of the ocean, on the beach. What would all of that rushing water eventually do to your rocks? And what do you notice? Well, let's see. All of the rocks look different, don't they? Even this guy looks smaller.
But in the one that I stirred it, I can barely see it.
That's wonderful. Thank you, Siddharth. How about Benito? What did you notice? What do you observe?
I observed that when I shake, I can still see the Smartie, but the water became blue.
Wow. So it mixed in the color of the Smartie. So imagine that was one of the soft rocks. It would the the outside layer of the rock starts to disappear and mix in with the water. Did you know that that's how sand forms? What? When you go to the beach and you step in the sand, that's broken shells and rocks, what you're stepping in. All right. And I think that's caused by the wind and the rain and the ocean waves. Wow, I love those ocean waves. All right, my loves. So did our hypothesis, this is a good question for a super scientist, did our hypothesis, what we thought would happen, come true? Was our prediction correct? That if we shake the water, it will change the rocks faster? Look at our control. It's barely done anything. Only the coating has come off of the M&M. Or everything else is pretty much the same. So our hypothesis, moving water will change it faster than standing still water. What do you guys think about that? Yes, Vashvik? Well, what about you?
Oh, standing still water. I put like I guess I put like I put like a gummy bear and some cereal and also like a cherry in each one of my things.
Oh, cool.
And well, cherry, the what's it called? The gummy bear is like it's weird. It's like curled up. It's wet. It's also like it's pruned.
Oh, it absorbed water. Oh, I see.
Yeah, and also the cereal, it is like it looks like it's about to break.
Oh,
I see like a crack.
oh, wow. So I guess the cereal was like a sedimentary rock. It was the soft one. Okay, Siddharth, I'm coming to you next. Thank you so much for sharing.
Yeah,
Jack.
but also the cherry, the cranberry that I put in, it's still the same.
Oh, so that would be more like our metamorphic or hard rock. Nice work, man. Thank you. I'm going to go to Ava. Ava, share with us, and then Siddharth, and then I think we'll move on. Go ahead.
When I was done shaking the water, the Jolly Rancher got small and it's clear now.
Wow, imagine that was a cliff at the edge of the ocean. That cliff would get smaller and smaller over time, wouldn't it? Yeah. Same thing if you're stuck on it, it's going to get smaller. Siddharth, show us what you were going to show us there.
See, the M&M's really brown.
Look at that. Oh, that really looks different. Thank you, guys. Okay, so it's okay if you can't do it. It's no problem. You can try this at any time. As a matter of fact, I also did a really cool erosion experiment. Can I share with you about that real quick? You can do this in your backyard. Get a plastic bucket or container. Square one is good. Or a paper plate. Pile up some dirt on one side of it. Pile up some dirt and grass and rocks on one side. And then get a watering can. Have you ever seen a watering can? Fill it up with water and rain on the soil. And watch it erode. Watch it move. See what happens to it. Okay, so I'm going to go back to our Nearpod and finish up. Our hypothesis was correct that the rushing water will erode candy much faster, and that candy represents our rocks. Much faster than still or standing still water. So let's move on through. And our conclusion, then now this is what a scientist would write down. They would write down what their finding was at the end. They wouldn't just tell somebody, they'd write it down. After all the shaking is done, you pull the candy out of both jars, and we notice that the candy in the still water did not change much, but the candy in the moving water was much smaller or changed color. So you have to be very specific and tell what happened. Beautiful. So here comes our erosion song. We're coming up to the end of our lesson. A cute little erosion song that we found. You hear it? Let's see if make sure we can hear it.
Shape of of land by moving pieces of the earth from one place to another. This is how we understand the changing shapes of the land. We can slow down or prevent changes by using the knowledge we have from science. This is how we understand the changing shapes
That
of
was
the
what I talked about.
Water and wind can change the shape of land, but we can plant trees or we can build a dam. This is how we understand the changing shapes of the land.
Wow, that was so neat. There's some experiments. A hair dryer also, if you blow on, if you take your Smartie real quick and you just blow on it, how long do you think it would take for it to change? Could you try it one day? Might take hours. Now, here we go. This is your turn to be the teacher. Tell me what I need to know about Earth's changes. How does the Earth change? What should I know to be successful? How are you going to prove it? Go ahead and show me, write me, tell me, send a picture, something to prove that I've got this. So this is it. This is the last thing you do. Awesome job, guys. We had a great
I
time.
have a question.
Yes, go for it.
How do you spell science?
Oh, well, I can actually write it right here. It's SCIENCE. Science. Oh, I have my first collaboration. Let's see what I need to know. Yes, Almo, wind. Wind is a force that will change the surface of the earth. Fabulous. Who else has one? Oh, here comes another one. Oh, Brooklyn, I love your earth surface picture. Johnny, look at the picture of erosion. Adeline, yes, well, I wonder what caused that erosion. Jaden, fabulous job showing the cycle of the earth. And what else? Oh, yes, the sun will fade away. Let me see, also dries up the water. Siddharth, good work on your experiment picture. I love experiments. Remember to write everything down. Oh, here comes Ava Marie's. Yes, a natural change is when rain. When it rains, we'll also make puddles, floods. Here comes Christina's, Blake's. I'm sorry, go ahead. Anybody have any other thoughts about what I need to know about the Earth's changes? What about fast and slow changes? Do certain things happen very slowly? Like if you blow on your Smartie, takes a long time. But if I crash into it with water, if a tornado hits it, will it change much faster? Huh? You guys think about that. Let's look at, there's Larissa's. Oh, Parisha, what's that? Talk to me about what that is. Energy? Is that energy? Lightning? Lightning will cause a very fast change. I liked it too. Arna, very nice. All right, my love. So what? You're really teaching me what I need to know. Look at Arna's The Changing Earth. How scientific challenges. What does that say? Let me open that up. Oh, it's a living planet program. So these people are trying to help by teaching us ways to protect and preserve the earth. Ooh, Siddharth, I like that. Let's look at this. Oh, wow, Siddharth, I like that. The water cycle. Ooh, brilliant. That's another experiment coming one of these days. Awesome job, guys. I love the water cycle. All right, you are free to go. I hope you enjoyed your time